Oh, that's why. There we go. Much better. All right. It was the wrong camera.
Oh, which is why it was blocked partially when you moved.
Yeah,
Okay, that makes so much more sense.
Oh, darn it. I didn't do that. There we go. Now we got Q&A app enabled.
Did you ever hear about the Doug Fisher thing?
Okay. You want GitHub? You want your account?
Yeah. The mobile cloud full. I can get to it too.
Okay. Oops. Come on. All right. Sign in. Okay, so do you know how to get to the right link? Okay. All right. Well, I think we're set. Looks like it's working. I'll double check to make sure it's working.
Okay.
Here.
You just pull up the
repo. All right, looks like it's live.
All righty.
I see you. Good.
Hey. All right. We've got a couple people. Wait one more second here. Okay, well, welcome to the virtual office hours. Today we're going to review the solution to the second assignment, both for the version A and version B. And we're going to talk about two different ways, or actually there's probably multiple ways that you could have completed this assignment. We're going to talk about two specific options in the persistence for the solution. So then go ahead and pull up the solution here on GitHub and share this with you. So first I'm going to walk through the solution to part A, which was doing the ratings and adding the OAuth. So the first part we'll go ahead and look at really quickly is we'll look at the configuration, if we can get it to work here. Right, we're going to go and look at the and we'll dive into here. We'll look at our application class and see what we did to add OAuth. Now for this, really the goal wasn't to show you how to reinvent OAuth from scratch, but how to take an existing OAuth system, in this case Spring, and show you what it looks like. The key thing that needed to be done in your configuration was just import the OAuth 2 security configuration that was provided for you. Inside of the OAuth 2 configuration, you can see more details about how that works. So basically, in the OAuth 2 configuration, there's a couple things that we're doing. One is we're disabling the cross-site request forgery checking, and the main reason for that is we're using a mobile client, and it's really hard with the mobile clients to keep track of those tokens easily. Instead, we're using the OAuth token, so we're allowing anybody to get access to the token authorization point and then go and request tokens. And then the rules that we're adding are that anybody that sends a GET request to any path other than the ones that we previously defined up here has to have an OAuth token with read scope. So this is just saying that somebody has to have authenticated, and the client, if it's sending a GET request to any URL, has to have read scope. Similarly, we're saying that any request that's sent otherwise for any other request method has to have the right scope. So you could also do this and scope it more tightly and say, well, this is only for put and post, but in this, or in delete, but this case, we're just saying anything else, we're going to default to requiring a right scope. And this has just been provided for you. This is an example. Again, most of the time what you're doing is just configuring the authorization of requests that are going to be there. And then the other thing is figuring out the client and user details services. And I provided an example here of doing that, which we're using for this assignment, where the user details service is just the in-memory detail service that Spring provides. And then we're just hooking up the client detail service to it. If you wanted to go and do this on your own and have your own user detail service that was persisted in a database, you could take the user detail service interface, you could create an implementation of it and add the appropriate Spring annotations, JPA annotations to persist it, or Spring data annotations if you're persisting in another database that's NoSQL, something like Mongo. And if you look at this interface, it's fairly straightforward on what to do. And then using this as a guide, you can see how to set that up if you just swapped out this interface. Now most of that was given to you. So I'm going to instead now go and focus on the pieces that you really had to go and write most of the code for. And that would be the controller that's here, and then the binary data controller, which is what I'm using to handle video uploads. And then we have the model, which we've created, which is the ratings of videos. So you should have already had the videos and the video status and all of this done from the previous one. The average video rating was provided to you as part of the specification. And what I did was created a user video rating to track the ratings by individual users. Now, there's different ways you could have gone about doing this. And this is one way that allows you to complete the assignment without using the @element collection annotation. So several people asked about the @element collection annotation and said, don't you have to have this to complete the assignment? And you don't have to do it. You can use @element collection, and I'll show that in a minute. But the way to do it without is you just create an entity for video rating. And in this case, we're just doing sort of the poor man's version of associations, foreign keys. We're just saying we're storing the identifier of the video that's being rated, and we're storing the ID of the user that's producing the rating. So this is just a standard JPA entity, and we've just created variables to store the ID of the video that's being rated and the user that's making the rating. And then what we do is we create the user video rating repository. And the way that we look up ratings is when a particular user tries to rate a video, we just use Spring data to create a method for us so that we can say, find by user and video ID. And what this allows us to do is find the rating, if it exists, that a particular user has given for a particular video. Now, there's other ways you could do this, but this is a very simple way to do it. And we can find all ratings that have been created for a particular user for a particular video. Now, the way that we use that is, if we go back to the controller, when somebody goes and attempts to rate a video, so for example, when we have this rate video method down here, one of the things we do is we add a parameter, and this was specified in some of the videos. You can add a parameter to take in the principal, and that's the currently authenticated user. Now, if you didn't have those rules that we saw in the OAuth configuration saying authorize requests, then there may not be an authorized user, which means that principal would be null. But since we said that every request, every path other than the path to get a token has to be authenticated and authorized, that means that this principal variable will always be provided by Spring and passed in. Now, there's other ways you could have done this with Spring pre-auth and other annotations. In this case, we're just doing a very simple approach, which is we're going to take in the principal as a parameter in the method. And then what we do is we just get the username of the currently logged in user, and then assuming that we can also find the video that they're trying to rate, so we're doing some sanity checking. So if we find the video and it exists, so it's not null, then we go and look up, has this user previously rated this video? If we go and look a little bit above here, we can see to do that, all we're doing is we're using our ratings repository that we just looked at to find any ratings by that user for that particular video. If we find a rating that's in there, then we go ahead and return it. And then down here, what we're doing is we are setting the rating. Now, one other thing we're doing up here is we're saying if there's a rating. So basically, we're looking and seeing, we're guaranteeing that this method will always return a user video rating. So if they've previously rated the video, then we're just returning the currently stored one right here where we say ratings.iterator.next. So this means that if they've rated a video, it's been stored in the database, and our query found it, then we're going to return the existing one. If our query doesn't find any existing ratings, then we just initialize a new rating object and return it. So what this means is down here in this method, when we look up the rating for a particular user in a particular video, and then we set it, we always know that we'll have whatever the current object is that's been persisted. Either it's their previous rating or it's a new rating, and then we just save it. So a user will never be able to rate a video more than once, because when we search for their video rating, if it exists, we'll find that existing object, we'll update the rating value on it, and then we'll save it. And then we can return the average rating of the video. If we scroll down here to the average rating, we're using a different method in our repository, our video ratings repository, where we just look up all the ratings for a particular video by the ID of the video. Now, this is one way to do this. This may not be the most efficient way to do it, because every time we're asking for a rating, we're having to search through all the ratings and collect them. So if there's thousands of ratings, this wouldn't be a very effective and resource efficient way of doing this, but it's one way of solving it for the solution that's a fairly straightforward way. And then what we're doing is we're just taking the ratings and we're using the Java 8 Streams API to produce the average rating from all of the ratings and returning that data. The other methods are the existing methods for reading get video by ID. We didn't have to change anything for that because we don't have to worry about users writing to it. Same thing for getting the video list of all videos. But if a video is being added, one of the things that we do is we make sure, and we first now have this requirement that we check to see if the video preview exists, because we don't want someone to be able to override a video. So if we already have a video with the given video ID, then we check and see if the currently authenticated user, the principal, the name of the principal, equals this owner variable that we've added to video. And if it doesn't, then we're going to throw an access denied error. So if there's no existing video, we don't do this check. But if there is an existing video, then only the person that is considered the owner of that video is able to write to it. And then whenever we're going to write to a video, one of the things that we do is we set the owner variable of the video to whoever the currently authenticated user is. So by passing in this principal up here, we're getting the currently authenticated user. And then down here, we're setting the owner of the video to whoever the currently authenticated user is. So if we pass the check that either the video doesn't exist or the owner of the video is the same person that's currently authenticated, then we go ahead and allow them to write to it. Regardless, we always set the owner to the currently authenticated user. Now, you might want to change that if you were using something where you could have owners assigned different ways, but for this example, we're doing it this way. The next piece was in dealing with the binary data being uploaded. And what we did here is we added some protections that you couldn't overwrite or upload binary data for a video that you didn't own. So again, we look up the existing video when a video binary data is being uploaded. If it's not null and the person that's currently logged in, the user that's currently logged in, is the same as the owner of the video, then we go ahead and allow the video data to be saved. If the video doesn't exist, well, that's a problem because you can't upload binary data before you've uploaded the video metadata. So we return a 404. If it's that the video does exist, but you're not the owner, then we default to throwing access denied. So you're not allowed to, upload or manipulate a video, it's binary data, if you aren't the owner of that video who uploaded it originally. So again, this is a simple way to do this. You could also do it with Spring annotations or other things. All of those are valid solutions. And when you're testing, the main thing is to look at the automated test and ensure that it passes. So there's lots and lots of different ways that you could do this with Spring. Another way that you could have implemented this is with @element collection, and I'm going to show a solution to 2B that uses @element collection. Okay, so for assignment 2B, we had very similar requirements that we had to go and implement. You can essentially do the same things that you did for the video controller in A. So in the methods to manipulate the metadata, you would need to do exactly the same things that you did here. You would need to take in a principal or use Spring annotations to make sure that the video exists, and then if it does exist, check to see if the person that's trying to write to it is the owner. So you would need something similar to this in the controller. The controller is going to be pretty much exactly the same for the video metadata parts. The big difference between A and B was the liking and unliking of videos, and then the part B or version B did not have the requirement that you upload the binary data and some of the other detailed things. But you would need to have the ability to upload video metadata, and you would need to have a check like this that the currently logged in user is the one who owns the video, and some way of seeing who is the owner. You could either store that as a variable on the video object itself, like we're doing here, or you could come up with some other scheme to do that, although another scheme is probably more complicated than is needed for this particular assignment. Now, for the second part of it, what you needed to do was to see who had liked and unliked a video. So in this case, we're showing a solution to B that uses @element collection, since a lot of people were asking about it, and we want to show how it works as opposed to how you would do it without @element collection. Now, if you wanted to do this with @element collection, in this case, what we're doing is we're going to store a list of all the users who've liked a video in the actual video object itself. Now, again, if you have large numbers of users liking videos and unliking videos, this probably is not a good solution because you're going to have all kinds of different performance issues. But for the purposes of this assignment and the limited requirements, we wanted to show a simple example. So in this case, what we're doing is we're just adding a set of all people who've liked a video, and whenever somebody likes or unlikes a video, we're going to add their username to this set of people that have liked a video. Now, you could do pretty much exactly the same thing with the approach that we used for the ratings. So we could have a video like object, and in the video like object, we could have the username variable and then the video ID variable, and we could set those when somebody likes a video. And then if we wanted to check whether or not a user had liked or unliked a video, or not, we would just look up based on the user ID and video ID any existing like objects that were in the database. If they were there, we could delete it if they were unliking, or we could add it if it wasn't already there and they were liking. If they'd already liked it, then we wouldn't do anything. So it would allow us to do exactly the same thing. In this case, we're going to do it with @element collection. So let's go and take a look at the controller and how this works. So what we want to do is look at the like and unlike methods. So the way that we're going to do this is, again, we're taking in the principal. So when somebody tries to like a video or unlike a video, they're going to have to be authorized, as we saw in the OAuth configuration. And so the principal is going to give us the currently logged in user. We're going to go and look up the video that they're referring to, and assuming it exists, because you can't like a video that doesn't exist, we're going to get the current list of users that have liked that video. So we're basically looking up that set of users, and then we're adding the currently logged in user to the list of users. Now, because we're using a Java set, it guarantees that there will never be duplicates. So somebody can't like a video twice because we're using a set to store the people that have liked a video. And we can check if this is a change, because if when we add this person's name, it wasn't previously in the set, then changed will be false, or it will be true. If it wasn't previously in the set, changed will be true. If that person had already liked the video, then changed is going to be false. And what we do is just down here, if it's changed, then we update the likes and we save the video object. If the user has already liked the video, in this case, we're just sending back an error 400 because they've already liked the video and they shouldn't be trying to like it again. The unliking works very similarly. When somebody submits a request to unlike a video, we get the currently logged in user. We find the video that they're trying to unlike. We make sure it exists. And then we go and look at the set of people that have unliked or that have liked that video, and we try to remove the user that's currently logged in from that set. If they had actually liked it before, then we'll go ahead and update the list of likes and save it in the database. If there was no change, meaning that the person tried to unlike a video that they had already liked, then we send back an error code. And so that's really the main difference, other than the binary data between part A and part B, or version A and version B, is just likes versus ratings, and whether or not, this is again showing two different ways of implementing essentially the same thing, which is you can use @element collection. So you could use @element collection to store a list of ratings associated with a video, or you could use @element collection to store a list of people who've liked a video. Similarly, you can use the sort of simpler approach that we showed, where you have each video, you have a video rating object. The video rating object has a username and a video ID member variable associated with it, so you can look up ratings by the user and the video ID. Or you could have a user like object with a username and a video ID, and similarly you could look up whether or not a user had liked a video or not, given the username and the ID of the video that they were working with. So you could solve this problem with either of those approaches, or there's also many other ways that you could do this. Again, when you're peer grading, you really want to focus on the things that are asked for in the evaluation, which the key one is going to be, can they pass all of the tests that are in the auto grading suite. So with that, I'm going to go and bring it back here and answer some questions. Having trouble reading the text. All right, take a look at that and pull it up. Any other questions from folks? Okay, we'll go and take a look at the forums. All right. See if there's anything in the virtual office hours forums. Oh, we don't have. Do we need to support dynamically coded, or currently there's a hard-coded stack list of 7 authorized users defining an OAuth to config. That is fine. You don't have to support dynamically adding users. I'll post this with Doug's account, I believe. All right. Let's go back and take a look at the next one. Do we need to support, let's see. Are we allowed to use code from previous MOOCs, e.g. video client with OAuth 2? Yes, you can use the code from the previous MOOC, and that's no problem. And Chinmaya, who's been working with us, Chinmaya is someone who took the MOOC last year and then came and worked with us here at Vanderbilt this summer and did a really awesome job, and is helping us also on the forums since he's been participating. Now let's go look. Assignment 3 question. Is it a must for the assignment to have a content provider, as I wanted to build based on code examples instead of former assignment submission? You can, as Chinmaya said, you could use 3B, which doesn't require a content provider if you don't want to use that. Okay, let's head back here. All right. In the real world, a user will have to create a user account. Are there already made libraries which can do this? There are some limited number of things out there, and you may or may not find anything that's complete for Spring to do this. A lot of times you have to write a lot of this functionality with email verification and these things yourself. There are some interesting projects that you can use that have some of these things built in. One of them is a project called Hipster, which I would highly recommend people taking a look at. See here, we'll go to Hipster. Hipster is a Spring-based, it's essentially a project that allows you to quickly build Spring-based applications, and it provides a lot of code generators for you. It has lots of different features built in, and so it's one of the options that you could use for dealing with pre-built user management and authentication. I cleared likes and like that when a video was overwritten. Okay, that's a perfectly fine solution. I don't think that that will cause any problems with the autograder. I'm assuming that you passed the autograder, but that's a perfectly valid solution to the problem if that wasn't actually specified in the assignment or in the autograder. I don't believe there was anything to test for that. So that's a valid way of solving that. Is there a secure way to store usernames and passwords for retained logins? So the answer is yes. There are very specific things that you want to do. So when you're storing passwords, the right way to do it is to use Bcrypt or something similarly strong to essentially create a hash of the password that is what you actually store. And so what happens is when somebody logs in, they're going to send their password, and you apply Bcrypt to their password to generate a hash, and then you compare it to the hash that you've previously stored. Now, the reason that this is good is if your website is compromised, or your backend web service or whatever it is compromised, whoever gets access to it isn't going to have the original passwords. They're only going to have the hashes that have been produced by Bcrypt for those passwords. So they can't immediately go and log into your service or know that user's password, which they may have reused on another website. Instead, they'll have to try to do it with a brute force mechanism where they'll try to generate hashes for different common words and other things in order to see if they match against the hashes in your database. But using other techniques like salt and things like that, you can make it harder for them to essentially figure out how those hashes translate back into plain text passwords. So Spring has built-in support for Bcrypt and also all kinds of other things. It was beyond the scope of what we had time to cover, but if you Google Spring and Bcrypt, you should be able to find a lot of documentation showing how to properly hash passwords with Bcrypt and Spring. It's a secure way for storing secrets passwords in apps. Android has and I have to remember the correct exact name of the class, but it's it's the Android Key Store, I believe is what they call the class. But the Android Key Store is a secure place to store encryption keys. And depending on your approach, there's also, I believe, some other newer facilities for storing like OAuth tokens. But it depends on your level of paranoia. If you are not worried about somebody getting physical access to the device or getting root access on the device, and you're really just focused on other apps not being able to read, let's say an OAuth token, then you could potentially store it in the the private settings for that app. If you are much more paranoid and you really want to get more serious about the security, the way to do it is to encrypt it when you store it, and then store the encryption key in the Android Key Store. So that way, if somebody gets access to the device, they're going to have to know the password to the key store in order to break into the key store and get your encryption key, and then be able to go and decrypt what you've stored. So the real serious way to do it is to encrypt it, store it privately in your app storage, and then store the encryption key in the Android Key Store somewhere. Now that would be a more advanced way of doing it. Could we do without element connection for 2B? I did it that way, just confirming 2A had user ratings and 2B had likes instead of ratings. Is that correct? Yes. 2B had likes instead of ratings. You could do 2B almost exactly like you did the ratings. So you could have again, a user like object that had a string username field and a long video ID field, so that you could look up whether or not a particular user like object existed based on the username and the video that was trying to be liked. If that object existed, you would know that that user had previously liked that video, and you wouldn't allow them to like it again. If that object didn't exist and they were liking the video, then you would create that object and persist it in the database so that its user field pointed to the currently logged in user and its video ID field pointed to the video that they were liking, and that way later you could look it up again. So that would be the way to do it without element connection. How can we learn more about Spring in practice? If we want to learn how Spring is actually used in industry and practical corporate implementations, can we do it? I mean, without getting a job at some company. Well, what you're seeing is all of the controller stuff, all of the things about persistence of data. Those things are realistic. Those are the actual Spring that you see. Now, would be different in one of these projects is the level of complexity. So you'd have more controllers, more code, more entities stored in the database. The way you would still, all of the sort of abstractions in Spring are exactly the same. So there's still going to be a user details service. It's just how that user details service is implemented and how it maps back to a database or some other store of users. Now, on the controller side, very similar stuff. You're still going to see controllers. You're still going to have request mappings. All of that code is the same. You're still going to have entities. You're still going to have repositories that you're using to look up those entities in general. I mean, again, it depends on which exact Spring projects they're using, but this is very real world of what you would see on a real project, just not as big. And there would be some other probably systems that you would be integrating with depending on what they had that would add new details to it. But overall, the structure is very similar to what you would see in a real world application. Okay. To check if the video was being overwritten, I used only the parameter name of the video. Is this okay, or should I check the ID? If all of the names end up being unique and you have a way of enforcing unique names for videos, that would be okay. So if you can guarantee that all videos have unique names, then your solution is perfectly fine. And that could be a valid solution, that I'm going to require that all videos have unique names. If all videos have a unique name, then you could simply check the name, see who the owner of it is, and then decide if that's okay. If you allow two people to upload a video with the same name but different content, then your solution would have a problem, because you wouldn't be able to differentiate which video they were referring to when they were trying to set the name. But if you have a system for managing that, that's okay. Will the Capstone be offered soon after the security MOOC ends? Yes, the Capstone is going to be offered right after the MOOC ends. We're going to get the certificates out. Hopefully there's no hangups like we had from the previous course with the grading system, but the certificates should be released really quickly, and then the Capstone should be starting up really quickly after that, and so people should be eligible as soon as these grades go out to sign up for the Capstone. Definitely encourage you to take that. We're going to have a lot of really great projects available for the Capstone, many of which we've sourced from our collaborators here in the Vanderbilt Medical Center, and interesting mHealth apps, mobile health apps. We've also got some other things from industry partners who've come up with some of the specifications for apps that get them excited. But there's going to be some really, really great projects in that, so we encourage you to take that. Okay, any other questions? All right, well, thank you so much for attending the office hours, and please definitely sign up for the Capstone, and we will see you next week in office hours. Thank you.